Dylan Bailey, who is a rather clever fellow, and was one of the participants in the formulation of a NAVIC. And I doubt that anybody in this room has actually participated in that. And that NAVIC is, for all of us, 0216, February of 16, that deals with how you inspect sailboat rigs. We should all know that, for those of us who do sailboats. But Dylan's on another subject today, and we have Dylan Bailey. Remote.
Thank you, Randy. It's my pleasure to speak with you guys this morning. I wish I could have made it in person. So basically what we're going to cover is NDT, different uses, different forms. NDT stands for non-destructive testing, and how you might be able to apply this to marine surveying, whether it's CMV inspections or damage claims. So what we're going to cover is limitations, pitfalls, various equipment that's used, proper inspection techniques, and I have some case studies towards the end, and a couple things that should be covered under your inspection reports, and also mentioned in your condition evaluation surveys if you're inspecting rigging, doing ultrasound, or any other type of NDT. So what are some of the forms? One of the basic form is visual inspection. We all do this when we do a marine survey. You really cannot beat the visual inspection. I think it's probably needs to be the most thorough inspection you do, from everywhere from the bilges, fiberglass tabbing of bulkheads, corrosion in metal boats, stress cracks in metals, stainless steel rigging. This is something that we're all doing. I like to take photographs of everything I can take photos of, and then study those photos on a computer screen. And I always seem to be able to see something that I missed while I was on the boat. Another form of basic NDT is tap testing, whether it's with a mallet, a coin, works well in carbon fiber. I've used a screwdriver, just like Mr. Lowell mentioned yesterday, since back when I was doing fiberglass repair and other repair work, and I still sometimes will grab my trusty screwdriver head and use that for tap testing. Getting into a little bit more advanced NDT would be dye penetrant testing. This is used on weld inspections, rig inspections. I started doing NDT work at my father's boatyard in Norfolk, Virginia, on rigs, on refits we were doing in the mid-90s. That's what piqued my interest in rig inspections and rig failures. Ultrasound testing, in its basic form that a lot of marine surveyors use, is on metal boats for hull thickness. As Andrew had mentioned earlier in his talk, it can also be used in composite boats, whether they're solid or cord construction. And it's a great tool for carbon fiber mast, carbon fiber hull, carbon fiber fixtures of any kind. But to get into those types of inspections takes quite a bit of training and trial and error. And also the equipment cost becomes more and more higher and higher, more expensive equipment as you get into the more complex materials. Thermal imaging is something that I use weekly in my inspections, whether it's electrical, mechanical, boat hulls. I use it mostly in damage claims now, but I have used it for pre-purchase inspections. This is a damage claim on a picnic boat. As you can see with the visual inspection on the bottom of the hull, I mean, there's no doubt that it has suffered damage, but other non-destructive testing will help you determine how far out that damage goes from what's visible. And I think that that's probably the best use of NDT, is to try to determine what you cannot see with the naked eye. So talking about rig inspections, this is kind of obvious on this wedge fitting that we have crevice corrosion. this is something that every marine surveyor should be looking for when they're doing a survey on a sailboat. You don't need any fancy equipment, a good camera, magnifying glass, a Scotch-Brite pad. You can spot these deficiencies. It's up to you whether or not you are comfortable with going aloft or allow a rigger to do that. But no matter what, we need to be inspecting from eye level down, and of course the chain plates. And the Coast Guard NAVIC is a good guide for doing those inspections, as Randy mentioned. And there are some examples of how to do a rig survey inspection report, which can come in handy if you want to specialize in just doing rig surveys. My background in rigging goes back to 1988. And I actively still do inspections, but most of them now are trying to figure out why a rig failed. And I'd have to say probably 90% of the time, this could have been caught during a normal CNV inspection when a rig fails. And here's one of the more obvious stainless steel fixture for this staysail boom here. Crack in a swedge fitting. Sometimes the cracks are obvious here with the rust. A lot of times they are not, especially on multi-hulls. Aloft, there's a lot of stresses. The cracks can develop under 10 years of age without any signs of corrosion. And usually the only way you're going to see these is with a magnifying glass or unstep the rig and perform dye penetrant testing. I like to use macro lenses on my cameras. I have a what's called a micro four thirds. It's basically like an SLR camera without the mirror. You can have macro settings on point and shoot cameras. Individual macro lenses for SLR and micro four thirds come in very handy for photographing small hairline cracks such as this in a chain plate. While doing a visual inspection of an aluminum hulled vessel or steel hulled, you do not need an ultrasound to find the corrosion in this boat or the pitting. I discourage anyone for relying on just ultrasound. We relied on ultrasound and visual inspections going back probably to the early 90s in our yard when we started building aluminum boats that were classed to ABS. It's very valuable form of NDT, but it can also miss certain areas of corrosion if you're not spending the time inside the bilge of a metal boat. I usually spend, say, if I'm doing a 100-footer, I'm probably going to spend 2 days inside the bilge of the boat before I ever even break out the ultrasound equipment to do the exterior. Tap testing can be used on everything. We pretty much inspect composites, carbon fiber, wood construction. It can be helpful in detecting framing on metal boats and tankage. Ultrasound is getting more advanced. This piece of equipment here that you see on this slide is what's called a flaw detector made by Olympus. I use pretty much all Olympus equipment. It's been a great company to work with, but there's plenty of choices out there equipment-wise. This is a Epic 600. This can be used for debonding of laminates. It can be used for weld inspections, and then also just simple thickness measurements as well. This is not the standard piece of equipment that I use for doing metal hull thickness. That is called a 38 DL. Which is a more simple ultrasound gauge that does thickness readings, paint thickness readings. I think it's very important, as someone who ran a paint crew for many years on new construction and refits on metal boats, that if you're inspecting a metal boat, it's a good idea to have a paint thickness reading. That can be done with a special transducer on a piece of ultrasound equipment made by Olympus. I believe GE Instruments do the same, and there's probably other companies I'm not aware of. But I use a separate paint thickness gauge made by a company called Positector. And if anyone wants to email me, you'll have my email at the end of this presentation. I'd be happy to send you links to any of the equipment I use and discuss it if you'd like. With thermal imaging, which I mentioned is probably the most common form of NDT I use on a weekly basis, there's two different forms or methods. There's a quantitative, which requires determination of a temperature. This is for electrical or mechanical inspections. You need to be a level 2 thermographer, which I am, or higher to perform these inspections. Having said that, you can still find elevated readings during a sea trial or behind an electrical panel with a simple thermal imaging camera if you understand the limitations of the equipment you're using. Most thermographers in the yacht industry are using what's called a qualitative, in thermography, tongue twister, and that's for hull inspections. It does not require determination temperature. What we're looking for is difference in thermal patterns of the hull that might indicate moisture, laminate separation, laminate damage, debonding. We'll see some examples of those. This is one of the cameras I use, and the one I've used for the past 5 years. I just purchased a new infrared camera from FLIR with basically the same specs. But I feel that a 320 by 240 resolution for the infrared is pretty much the minimum that I can use when performing inspections of hulls. I can use something as simple as what's called a FLIR 1 that attaches to a phone for engine inspections, electrical inspections, but the resolution is not good enough for me to determine laminate damage or debonding of laminates. Couple examples. Thermal imaging, you'll see a lot of the images in here because mostly, it's easy for me to walk you through what we're seeing here, whereas ultrasound is not quite as easy for a presentation. But what we're looking at is these two arrows and a green line. This is moisture that entered in from a through hole that was added onto a quart hull sailboat for air conditioning, which leaked. Foam core, but still that moisture traveled down to the line that you see on the bottom here of the hull and ran aft. This is a more severe case of moisture in a hull on a center console. You can actually make out the kerf lines of the core in this image, in the center of the image. My cursor will not show up on here. I'd point this out, so I apologize for that. The areas of the yellow, greenish, almost orange pattern that's along the chine of the boat, those areas where it's actually becoming debonded. This is I forget the core material on this boat, if it was balsa or if it was foam core. Wood hull boat. That's basically what we're looking at is moisture and rot in the planks. This is a deck hatch on a large yacht. And I'm not exactly sure, but I would assume that the hinge has been leaking for a long period of time. We can see the thermal pattern of just to the inside edge of the hinge. What we're looking at here is a fiberglass chain plate on an Irwin. Island Packet sailboats have them as well, and some of the Taiwanese built yachts. There's a vertical pattern in this image, which is the stainless steel bar stock chain plate. And the blue kind of splattered pattern here, for lack of a better term, is moisture that is trapped around the chain plate. In my opinion, anyone who has embedded chain plates in the fiberglass should pull them, but often the boat owners will not do it without a little bit of a nudge. And often this is the nudge they need, an image that shows that there's been water trapped around these chain plates. Now, whenever looking for moisture in a hull or performing any type of NDT, it's not wise to rely on just one type of test. So if we're looking for moisture, we like to back that up with tap testing, moisture meter readings, visual inspection. As you look on this image, we're looking at basically a bilge of a catamaran. I found moisture on the exterior of the hull using infrared and thermal imaging. Moisture meter confirmed it on the exterior of the hull. Come inside the boat, look at the bilge, and we see a crack at the bilge sump, water stains. That is where our water is entering into the core of the boat. Moisture meter, I use an Aquant protometer. I don't know if they're still made by GE, but they were owned by GE for many years. It's a great meter. Still, nothing beats actual destructive testing. There are limitations to moisture meters. Stainless steel fasteners will trick the meter, any type of metal. Surface moisture will not on this Aquant, which is very beneficial, especially if you're in a bilge. I try to dry it up as best as I can and then put the meter on it. And if the meter is in the red area, and if the infrared images are showing anomalies that are consistent with moisture, then I can mark that area out on the hull, photograph it, and talk to the boat yard about pulling some core samples so we can determine how bad it is. And this is what we should be seeing. Well, this is extremely dry. I don't see very many boats that are that dry, but we want to see something that is in the green area of the meter. Debonding, we're looking at this is a picnic boat that was picked up in slings improperly, and caused a little bit of damage at the deck edge. And you can make out the cove stripe on this image. The red and the white is where it's become debonded. So when this was cracked on the deck edge, a quick temporary patch had been put there without any fiberglass, just some filler, and quickly spray painted over and is sold. And then when the owner of the boat was having it surveyed a couple of years later, they noticed that there was a large area of debonding. We used thermal imaging, some tap testing, mapped it out so it could be cut out and repaired. Catamaran hull. This is the hull of the boat that was in a previous photo slide of the bilge. The image on the right is an anomaly. You can see the difference in the pattern. It's bluish green color, and then we have that bit of an orange pattern there that's indicating an anomaly, which could be moisture. It could be a separation from the laminate to the core. Tap testing, I heard an anomaly, which was indicated debonding, and then went inside to see, they take the moisture meter readings, marked it out on the hull so that the boatyard could cut out that piece of laminate, remove the wet core, put new core in, and then complete a repair and launch the boat. And then also did the repairs inside the bilge, which led to the moisture intrusion to begin with. As if we don't stop the moisture intrusion, then we're not going to solve anyone's problems. Laminate damage after a fire. The area on this motor yacht that is basically the bridge, the cabin sides, the upper part of the image. The damage to laminate was obvious. Along the deck edge where we see the yellow and the red of the image, that was somewhat obvious as well. There was a lot of blistering in that area. What was not obvious was areas on the top side of the hull itself. And the aft port, you can see this greenish anomaly above the port running down to the water line. After that is a more uniform shape, which indicates a structure. When using infrared, if you're seeing shapes that are uniform, those are going to probably be hull structure. But when you see anomalies, which basically just lack of a better term, look like a blob, that's what you're looking for. That's going to indicate that separation or laminate damage or moisture. And often an anomaly that is moisture and one that is separation of the core and the laminate will look the same. And this is where the further testing comes in handy with using the moisture meter and then your tap testing. Carbon fiber laminate. This is a edge of a dagger board that the sander had got a little bit zealous with. We heated up the fibers with an infrared lamp and then imaged them as they're cooling. And what you're seeing is you're seeing those broken exposed laminates, which is the white in the image. This is what's a different color palette. So I tend to do all my infrared imaging in black and white, a grayscale. It's easier to focus, easier to see on a small screen. And then I process the images in software. And then I can change the color palette, which will allow me to highlight the different anomalies and deficiencies. And I will never comment on what I find in the field because that will lead to mistakes. So you have to be very aware of shadows from clouds if you're outside, people in the yard, cars driving by. And this is very difficult to be aware of this while you're imaging and concentrating. So when you put it in the software, you can switch between a digital image and the infrared image. When you see an anomaly, I switch over to the digital image and I look for a reflection. I also take images at different angles and compare those images to each other. The last thing you want to do is make a recommendation to pull a core sample or cut into someone's boat without being, say 80% certain that there's a good reason to do so. Grounding damage on this keel of a J boat, it is the damage was obvious at the keel to hull joint. The damage was not so obvious at the area where the keel joint meets the hull, makes that turn. Laminate damage during a grounding on a sailboat. Same type of damage, different boat, I believe. Saw an image earlier about a carbon fiber inspection. When doing carbon fiber, there's two forms of inspection. The ultrasound with the correct transducer, correct settings on your equipment, and then the thermal imaging. I think that both of those methods need to be used when inspecting carbon fiber, along with various tap testing techniques. I just think it's my ideal form of inspection with carbon fiber is to do thermal imaging first. I process the images in the software. I come back, I mark them on the mast, dagger board, hull, whatever I'm imaging, and then I perform the ultrasound to see if the ultrasound confirms that there's an anomaly as well. Carbon fiber mast. This is an anomaly that showed up after a lightning strike where the radar is attached to the mast. There were multiple anomalies on this mast. So when these images were processed, I was looking for anomalies such as this in this image. They were marked and then ultrasound, to confirm. And then the next step after your non-destructive testing would be to actually break out the grinder and do destructive testing. Thermal imaging can be very helpful with hull structures, whether it's metal, wood, composite. This is a fiberglass hulled boat, and we can make out the transverse framing and longitudinal framing. If I'm inspecting a boat that's been dropped, run aground, what I'm looking for when I'm doing the thermal imaging is I'm looking for nice, even thermal patterns of the structural members. If there's a break in any of these patterns, it could very well mean that there's been core shearing from a foam stringer, separation, cracking from a frame. This is on a small center console. This is an area where this anomaly runs along where there's a longitudinal stringer, and then there's a break which looks like a limber hole. And then the only way to confirm whether this is damaged or a limber hole, of course, is to get inside the boat. And sometimes that means using borescopes to access that area. I've also found that a GoPro camera with a flashlight and a stick is very useful in small boats like this. As I mentioned, with defining structural members, I will use thermal imaging for aluminum, steel. It's not necessarily saying that you can see corrosion with thermal imaging, but you can see moisture underneath paint and fairing compound, which means there's going to be corrosion or the start of corrosion underneath it. You can also find water that's trapped in forepeaks, lazarettes. I've also found corrosion in keels and ballast pockets of keels. I never rely on the thermal imaging as being the one method for this, but I will always give it a try and see what I can find. A lot of times I'm pleasantly surprised. Also being able to see the hull structure itself, at least the framing. Sometimes the stringers are a little bit more difficult to spot, will help me map out my inspection. After I've inspected the interior, I do my thermal imaging, I can map it out the next day. In this image, if we look down on, this is a sailboat, and if we look at the bottom of the image, we can make out the ballast area of the keel. This is on a classic aluminum sailboat, Spartan Stevens design. Just an incredibly beautiful boat, very well maintained. But unfortunately, there had been some, lack of a better term, shoddy repair work done to the keel previously. And what we're looking at in this infrared image is the side of the keel. And this is after the boat is warmed up during the day and it's cooling off around sunset, early evening, which is my favorite time to take infrared images. It's the least amount of work for me as far as warming the hull. I let the sun do it. It's called solar loading, and let it cool down, take the images. The blue arrow is pointing to a very poorly installed hull plate, or I should say keel plate. The red arrows are actually pointing to where there is weeping of corrosion from the weld. A couple of these were visible in tiny little blisters in the paint, and some of them were not. The one that is the last arrow on the bottom was not visible to the naked eye as a blister. During normal CMVs, this is a great tool for taking images of the engine, generator, exhaust system. I've found worn hoses, not just what you would expect on the engine itself, but on the exhaust system. After the sea trial, I will put these images in the software, and then I can take temperature readings in different areas of the engine as well. It's nice to be able to go back and review your data from the day, especially if the weather was rough and you're bouncing around in a small engine space. Electrical inspections, it's not as easy as taking a image and saying something looks hot. Here we have two terminals attached to breakers. One on the left is a nice even thermal pattern. The other one on the right looks hot. And as you can see, the temperature is 143 degrees. Everything else was around 90 degrees, so there was a deficiency there. But that same terminal there could be 80 degrees and still look hot. That's the importance of being able to actually measure the temperature in performing electrical inspections. This is a breaker. I think this was a main shore power breaker, and it's not, as you can see, there's a little bit of white on this image where it's attached. It was definitely hot. I forget what the temperature was, but the wire itself is starting to heat up. So get into a couple of different case studies here. Hull moisture, you usually get a call from someone, a captain or a boat owner. Boatyard was doing something, drilled a hole, cut out a little blister, found some water. In this case, this gentleman purchased this new, not new, but 3-year-old, new to him, 100-footer, and they're on a cruise to the Bahamas. And after crossing the Gulf Stream in a little bit of rough weather, he steps out of his bed and his carpet's wet. So, of course, he's in a panic and nervous. I think I would be as well. They traced the water coming in from the hanging locker, but they were not able to find a source for it. The ports weren't leaking. The through-hull fittings were not leaking. Got it into the boatyard, and then they discovered a couple of the fasteners inside the hull were dripping water. So basically, the builder had just fastened everything in the side of the hull, not to blocks, but to the hull itself. That wasn't where the water was coming in from. So that was still a mystery. I imaged the boat, allowed it to heat up with the sun. This was in Fort Lauderdale. Imaged it in the afternoon. And this pattern that you see along the chine towards the bottom of the image, these dark areas, they're fairly uniform. So that was really interesting. It's not what I would expect when finding moisture in a hull. Usually moisture in a hull looks like someone just sprayed it with a hose, and it's kind of going everywhere. But this was an even pattern. It ran along the chine and it went up to the anchor plate, which is where we ended up finding out the water was coming in, and it would come in as they were motoring into a head sea and make its way aft. Here's changing the palette. You can see a little bit more of a dramatic image. This was one of the worst areas of the boat. It seemed to be this was where all the water was settling and making its way into the owner's stateroom. So I used thermal imaging, moisture meter, tap tested the hull, and then I marked everything out with blue tape to basically show that pattern of where the water was traveling. And if you look at the 2 port lights on the left side of the photo, you can see where it looks like it was actually coming in from the port light as well. But we were never able to confirm that. That's a solid fiberglass frame, so it was doubtful that it came in from there, but it was making its way to that point and basically hitting a dam and then going upwards. And the reason why this was traveling is none of the kerf lines in the foam were filled, and neither were the seams in the sheets of foam. So it made, it was all these little canals for the water to travel through. So you go inside the boat, use the trusty moisture meter. You can see the boatyard had already drilled a small hole before I arrived, trying to figure out what was going on. That's right next to the moisture meter. But we were in the red. We were getting very high readings, elevated readings throughout the boat. And the infrared images were indicating anomalies that were consistent with the moisture meter readings. And tap testing, even though this boat was only a few years old, the laminate had started to separate in a couple areas, which you could see if you looked at the boat from the ground at an angle. You could see some blistering, and the tap testing confirmed that as well. So our next step is you drill a hole, and this is what was running out. So, and after that, they decided to cut one of the blisters out, and all those waters started pouring out. We could see that the kerfs were not filled. Let's see if this will play. It's quite a bit of water just in one place. Okay, so on that boat, I used multiple different forms of non-destructive testing, and then we ended with destructive testing to know the full extent of it. And then the repair plan had to be made with the captain in the yard. Drying of the hull and repair work took about 6 or 7 months. But it's back in service, and the owner's still using it, but at a great cost. These are 2 dagger boards from a high performance, two rudders, retractable rudders from a high performance catamaran, carbon fiber. This is a staged photo just to get the lighting and the building for this photo. I did not perform the inspection here. I performed it in a part of the building that had no natural light coming in. If you can see the light and the shadows on these rudders, this will all cause problems when you perform thermal imaging. The small yellow lamp that you see there is a paint curing lamp. It works great for providing a nice even heat. I cannot do a whole section at a time. I mean, could do a section at a time, but not the whole rudder at one time. So I do a section of a rudder or a mast or a dagger board, and then I let that cool, image it, and then move it and do the next section. Just to do these 2 rudders probably took me 2.5 days. That included the ultrasound. This is one of the images, grayscale. You can see the white part of the image. These lines are foam stringers inside the rudder. I was able to get construction drawings. It's a great idea, no matter what type of boat it is, if you're performing NDT, to have a laminate schedule, construction drawings, as much information as you can before you start your inspection. We have the same rudders. In this image, you can make out the multiple layers of laminate, carbon fiber laminate, and then we have some anomalies that these blue arrows are pointing to, which are basically voids in the layup. This is using an Olympus Epic 600 flaw detector. I forget the transducer I was using here, but it's a transducer that was spec'd by Olympus for this type of inspection. And Olympus and other companies are great for us. If you can actually get a test sample of the material that you're going to be performing the ultrasound on, they will make a suggestion on what transducers to use. If not, then they will give you a list, and it's just kind of a crapshoot on buying 2 or 3 different transducers. Eventually, you'll have a whole toolbox of transducers to choose from, and it's trial and error to find out which one's going to work best. During that inspection, what we ended up finding, there's not an image of it in this presentation, but on one of those, the thermal imaging actually showed that one of the foam stringers was missing out of the construction. That was a little surprising. So after our inspections, we're going to need to prepare a report. If you've used non-destructive testing beyond a visual inspection, I believe it needs to be in your report, whether it's a CMV report or you're performing an inspection report. I think that when we're doing CMVs and pre-purchase surveys, we need to be putting in the moisture meter we used, any test equipment was used, and the condition. And the reason why I say this is because down the line, if someone has to follow up on a damage claim or another pre-purchase survey and finds an anomaly, and someone hands you a survey report and says, here's my previous survey report, it's helpful if I know how that boat was inspected when I go to inspect it. So I always list the methods in my NDT report. And this is an example of one of my reports where I was doing a hull inspection on aluminum, I think it was 120-foot Broward, and list where I took the ultrasound readings, and just give a little synopsis of how that was performed. Document the conditions. This is very important if you're performing thermal imaging. and then list the equipment and the calibration data that you might have, transducers that were used in the inspection. And take good photos and have clear explanations of those photos. Don't just rely on a photo with an arrow without a good caption. Even if you were explaining this verbally to your client, you're not sure if this is going to end up at an insurance company one day, or an attorney's office, or another surveyor. And just as we do in our CMV reports, or we should, where we list standards, CFRs that are used, same thing, list whatever you referenced here. The first one is for metal boats, and the second one would be for a rig inspection. There are other standards that you might be using. If you're doing a classed vessel, you're going to be using standards from that class organization. Infraspection Institute, which is an independent training certification firm. They have their own standards. They actually have a standard for performing thermography on yacht and small craft, also with electrical systems, machinery. ASNT has standards, the American Society of Non-Destructive Testing. So there's a lot of resources out there for performing these types of inspections that go beyond just taking certifications and training. So here's my my contact information. You can email me or text me any questions. You can we can try to answer questions right now if that works. I'm open for that.
Very much, Dylan. Does anyone have any questions for Dylan?
Yeah, Dylan, can you hear me?
Barely.
Can you hear me now?
Yes.
Hey, it's Mike from the Southern Star. I just saw you put my boat on the screen there. Just know we did fix the leaks in the deck.
Yeah, right. I remember that inspection. Funny.
How weird is that? Any more?
We'll see you out there.
Yeah, but thanks for sticking with it, Dylan. Sorry it took us a while to get the IT sorted out, but we got there in the end.
We did. I hope I didn't rush through that too quick. It's a little bit different when you don't have the audience in front of you. But like I said, if anyone has any questions, just reach out, contact me. And it was a great honor to do this with you guys. Hopefully I'll make it in person.
It's beautiful, and thanks for being with us.